Good afternoon. We're going to do circles today, and there's a lot of circle basics I'd like to go over with you, just to make sure we're on the same page, right? Some basic languaging. Okay, so you need to know what a radius is. Okay, most everybody does, but I got to cover my bases. Radius starts from the center of the circle and moves out to the perimeter or the circumference of the edge of the circle. A diameter goes right through from one edge through the center to the other edge of the circle. And here's one a lot of people seem to forget, and it's called a chord, and the chord runs from one point on the edge of the circle to another. The longest chord is the diameter. Okay, what else? We have a central angle whose vertex is the center of the circle. And then we have our formulas. We have area and circumference formulas, which a lot of people forget or they mix up. Now, luckily, they give them to you on the SAT. So if you space out, have a brain fart in the middle of the test and you just forget, or you just always mix them up and can never get them straight, and you need to confirm, go to the front page of your math section, either 3 or 4, they're both places, and you can get everything you need there. However, it does take time to do that, and I would prefer that you know how to do it. You memorize these, so I'm going to give you a way to memorize them. Circumference, well, a student told me this years ago, and I've never forgotten. It's a little song. She says, twinkle, twinkle, little star, circumference equals 2 pi r. Okay, so if you remember that for circumference, the other one is area, and that's pi r squared. Okay. I think that's all I want to go through for now. And then I would like to show you some easier type questions that you might see on the test. And let's go. All right, so one type of question I've seen is they'll put an X right through a circle, and they'll tell you one of the angles is a right angle. Well, this is a straight line. And so if one of the angles is a right angle, that means the ones next to it are right, which means that all of the angles are right angles. All right, so what that means, now let's just pick a couple of points. Let's pick A and C. And let's say they're asking you for the length of what they'll call minor arc C. Minor arc means it's the shortest distance from A to C. You wouldn't go all the way around, the long way around the circle. Okay, so we want to find AC. And let's say they tell us that the area, no, let's say the circumference is 28. All right, now we know that AC is going to be the same as this arc because the angle is the same. Right, they're all 90 degrees. They're all the same proportion of the circle. So this one's also going to be the same. And this one is also going to be the same. So in other words, this arc AC is 1/4 of the entirety of the circle, which means the circumference is, means the arc is 1/4 of the circumference. That means the arc would be 7. Okay, so that might be a question they would ask. Let's see, another one. I won't say it's easy, but it's easier than some of the ones that we're going to do. They might give you a circle with a, let's say that's the middle, like that. And they might say that this is X, and we've got A and B, and we'll just label, we'll label that O. And then they might say that the arc AB, they'll say minor arc AB is 5. And Then they'll probably give the radius, and they'll say the radius is 10. Okay, and they'll ask you, what is x? Okay, now this might seem like a strange bit of information to give, but I have two things I want to say. One is, and I just want to make this degrees here. One is when you feel that the question is not giving you enough information to solve, this is what I want you to be thinking of. Part over whole. Because they give us a part, right? They give us a couple of parts. They give us the part x, which they want us to solve for, right? And that x, degrees, is the part of an entire circle that has 360 degrees. They also give us another part, and that is this arc. The arc is part of the entire circumference, which would be the whole, which reminds us that circumference equals 2 pi r, and luckily we have the r, so we can just plug in the r, which is 10, and our circumference is going to be 20 pi. So that's our whole. And now we have this lovely proportion. The reason why we can make them equal is because they're proportional. I'll show you something. The way we create this angle here encompasses this green arc. You see that? Goes from this end of the angle to this end of the angle. That's why they're proportional. Okay, so now we can cross multiply, and we get 20 pi x equals whatever 360 times 5 is. And I'm just going to put that on my calculator. I'm just going to assume that we are in the calculator section. 20 pi, and we're going to get x equals 90 pi. That is our answer for x. Okay. What else might they ask for? All right. Here's another one. I'll do it up here. All right, let's say, actually, what they might do is give a word problem, and there's no picture. So what do you do in any geometry? You draw the picture. And in fact, it doesn't even have to be geometry. Anytime they're giving you any sort of word problem and there's no picture, you have to draw it. Okay, so let's say they say couple of points lie on a circle. Okay, which means let's just say they're A and B again. You don't know where they are. You're going to just put them somewhere. It doesn't matter. And they're going to give you a radius of 1. All right, and then they say the arc, so the minor arc AB, and I'll put it up here. AB is pi over 3. Okay, and then they ask a question. I'm going to write it down. So they'll say, what fraction of the circumference, I'll label C, what fraction of the circumference is arc AB? Now, literally, when they give you the word fraction, the answer is a fraction. All right, so what this means is out of the entire circumference, how much or what fraction of that circumference is this little green arc? So again, we go back to part over whole. Okay, that's what we're going to use here. All right, so the part is the arc, and the arc is pi over 3, and the whole is, well, we have to figure that out. Circumference equals 2 pi r. We've got the 2, we've got the pi, and we know the r is 1, so the circumference is just 2 pi. So that's our whole. And we'll just bring it down here. We've got pi over 3 divided by 2 pi over 1, which is the same as pi over 3 times 1 over 2 pi. Okay, so that's going to be pi over 6 pi. There's an implied 1 over here before the pi. So when the pi's cancel out, we are left with 1/6, and that's going to be our answer. Okay, so those are some of the easier circle questions. Now, let's get into some of the more difficult ones. Okay, so I think what I would like to do is start with the questions on, on the actual test that we're going to review, because there are a couple. So let me clear this out. And let's begin with test 1, section 4, number 24. And it reads, which of the following is an equation of a circle in the xy plane with center 0, 4, center 0, 4, and the radius with an endpoint 4/3, 5. Now, I don't want you to freak out because I'm going to show you how to get right through this problem. Okay, you don't have to understand the radius of the endpoint. You don't actually even need to draw this. What you do need to know is the equation of a circle. All right, now I'm going to advise you to do what you can to memorize this. Okay, it is x minus h squared plus y minus k squared, and all that equals the radius squared. I know that's a lot of letters, okay, but let's just break it down. You're familiar already with x's and y's. You're also familiar with r for radius. But what you're not familiar with is the hk. And the hk is simply the coordinates for the center of the circle. Okay, now they tell us the center. And we know the center is hk, right? So we can put the 0, 4 over the hk, and we can put it in the actual equation too. And then I'm just going to bring down this equation here. So what we have is x minus 0 squared plus y minus 4 squared, and that still equals radius squared. Now, well, you know what? I'm going to simplify it. X minus 0 is just x squared, and then everything else is simply going to stay the same. Now, I want to look at the answer choices for a moment. And you'll see, if you haven't already, you should have noticed in all my lessons in math, I'm always saying, go to the answers, look at the answers and see what you can eliminate. So if we look at, well, let me put this in red so you can see. We're looking for an answer that looks somewhat like this. So every answer has x squared, so that's not going to help us. But then we get to the y's, and some of them are y minus 4, and some of them are y plus 4. Well, we want the y minus 4. So we can get rid of b and d, which have y plus 4. Okay, now let's look at the difference between a and c. Because, in fact, they're exactly the same, except for what they equal. So a says 25 over 9, that it equals 25 over 9, and C says 5 over 3. Now we know that an equation of a circle is the radius squared. So A has to be the number. It has to be the answer because A is literally C squared. Okay, so it's got to be A. You don't even really have to understand anything more than that in order to get this question right. So I love that. This is why I like being an SAT teacher. I get to show you all the tricks of the trade. Okay, so I'm going to get rid of this. And we're going to go to test 2 now. Test 2, section 4. And it's numbers 24 and 36. So let's go to 24. And there is a kind of a longish equation. 4x minus 2y, it equals -1. And it says the equation of a circle in the xy plane is shown above. So this is the equation of a circle. And they want to know the radius. So remember, it always equals radius squared. So whatever we get at the end, we're going to make a square root of it to get the actual radius. Okay, now what I like is to bunch together the x's. So I'm going to rearrange this. So we've got the x's together and the y's together. And you'll notice I have some space in here, and I'm going to show you why. So in order to get this mess looking like, I'll just draw this really small, x minus h squared plus y minus k squared. So this is the equation of a circle up here, right? It doesn't look like that yet. Okay, we want to get it closer. And what we need to do in order to do that is something called completing the square. Now, if you know how to do this, great. If you don't, check it out. The math is super, super simple. Okay, just have to remember a thing or two. So we're going to take the x's first. Okay, because this is right. So these are the x. This is the x section. This is the y section. So we're going to do the x's, and you're going to look at the number that is attached to the x. And you go, I'm going to put it down here. The first step you do is you have it. You divide it by 2, and you get 2. Then you square it, and you come back to 4. All right. So this is the thing. What you do to one side, if we're going to add 4 here, we're going to add 4 here. So the first step is divide by 2, and the second step is square the result. All right, now we're going to do the same thing for the y's. We're going to take the -2. -2 divided by 2 gets you -1. And then step 2, we square the result. -1 squared is 1. So we're going to add 1 here, and what we do to one side of the equation, we do to the other side. Now, you can see that the -1 and the +1 cancel out, and we're left with 4. The question is asking for the radius. So in truth, we don't even care about the whole left side. We only care about the right side because that's our radius side. And remember, it's always equal to r squared until we square root it, right? So if we get r squared equals 4 and we square root both sides, we get r equals 2. And 2 is our answer, A. All right, now I want to point something out to you, right? For those of you who just are not down with completing the square, you don't feel like learning it, it just feels like too much. It's okay. I'm not going to show you how to get all the way to the answer, but I'm going to show you a shortcut so you can get it down to 50-50. And it all hinges on the fact that you know that the equation of a circle always equals r squared. Well, you can look at C and D and see that they are the squares of 2 and 3. In other words, 2 squared is 4. 3 squared is 9. We want the radius. It's not going to be C and D. So you get it down to these two answers, and you can guess from there. All right. Now, the next one is number 36, and I'm definitely going to clear this out here. And let's do 36. All right, we've got this nice picture here. All right, we've got a couple of points, and we got a center. We've got a some radii. We've got a line that's tangent to the circle. And by the way, tangent means touching. Okay, so if you have a line that's tangent, right, it could go out this way too. This is touching the edge of the circle. Now, here's an important rule. Oh, they say that M is 60. All right, here's the rule. When you have a line, when you have a radius and a line that is tangent to that radius, you form a 90-degree angle. And the same would be true for up here. You have a radius and you have a tangent and you form a 90-degree angle. So check it out. You've got a 90-degree angle. You've got 60 over here. What you should be thinking is, hey, that sounds like 30, 60, 90 triangle potential. And you would be right. That's exactly what you should be thinking. Now you can create, but we don't have a triangle, right, yet. So we have to create a triangle. And you can create a triangle by going from L to N, but then you split the 90-degree angles, which is not so good. So your only other choice is to draw it like this. And now you have two different triangles. You've also split the 60-degree triangle into two 30-degree triangles. So here becomes your 30, 60, 90 triangle and 30, 60, 90 triangle. Okay. Now, I have to say, we have not even started reading the question, and look at all the work we've done. Okay, so as always, when there's a picture, the first sentence is going to describe the picture. So we don't care. We don't have to read it. We can look at the picture and see what it says. All right, so we're going to go right to the question. And that says, if the circumference of the circle is 96, and I'm going to stop, write C equals 96, what is the length of minor arc LN? So minor arc LN goes, this is shortest distance from L to N. I should probably do that in another color. Let's do that here. There we go. Okay, we want to know what LN is. Now, check it out. We've just discovered that from here to here, right, this angle, that big angle, is 120 degrees. Notice how beautifully it reflects the arc. And in fact, this angle encloses this arc, which means that there's a proportionality. So where there's a proportionality, there's also, in geometry, part over whole. We come back to this again. So we have this big 120-degree angle here. That's the part. We know the whole is 360. Can cross those out. And 12 over 36 reduces to 1/3. So this means that there's a proportionality. This big angle is 1/3 of the entire circle of that angle here. Likewise, this arc is 1/3 of the entire circumference. Well, we know the entire circumference. It's 96. So you can think of this one of two ways. You could say, well, 1/3 is the same as dividing it by 3, and I get 32. Or you could say 1/3 of, always multiply, 96, right? So this is, of can always be translated as multiply. That's 96 over 3, again, 32. Either way, you get the same answer. Okay, great question. Love that question. All righty. Now, what other questions can they give you? Oh my goodness, so many. I'm going to erase this here. Okay, now, perhaps, let's see, what have I seen? I've seen this kind of question. Very similar to what we just did. It might be like A, O, and B, this. And they might say, this arc, AB, is 2/5 of the circumference. Okay, if they say that, again, it's very similar to what we just did. We have this angle, which essentially encloses this arc, and there's a proportionality. So if this is 2/5 of the entire circumference, then the x is 2/5 of the circumference, in which case you would say, I'm sorry, not of the circumference, of the circle formed by that angle. So 2/5 of 360, right? You would do it like that. It would be 720 over 5, which would be 144 degrees. Okay, so that might be, it's the same kind of thing, just asked a different way. All right, let's check out another kind of question. Sorry for the delay. I'm just flipping around in my, oh, here's a good one. I've got a book. Okay, so let's say there's no picture at all. Of course, like any good geometry student or any math student on the SAT, you're going to draw it out. So let's say they say there's a circle and points A and B lie on the circle. Well, of course, you have to draw the circle because you don't know where they're going yet with it. A, B, you don't know where A and B are, but you can just make it up. And now let's say the circle has a radius of 1. And then they say there's a minor arc AB, and that has a length of, let's say, pi over 3. And the question is, I'm going to write it out. What fraction of the entire circumference, I'm going to shortcut it though, what fraction of C, that's the circumference, is length AB? So again, this is a part over whole kind of situation. See how there's this theme running throughout geometry? Okay, the part is clearly the arc. It's part of the whole circumference. And again, here we have to find the circumference. Circumference equals 2 pi r. And we have the r. They told us it is simply 1. Okay, so that's just going to be 2 pi is the whole circumference. So we're going to put that as our denominator. And then we get pi over 3 divided by 2 pi over 1 is the same as pi over 3 times 1 over 2 pi. And we get pi over 6 pi. There is an implied 1 here. So when the pi's cancel out, we end up with 1/6. And that's our answer. Okay. What other? There's one other kind of question I recall. And it would be something like they would give you an equation of a circle. And let's say it looks like that. And let's say it equals 25. Okay. And then they say, which of the following points, and they would give you coordinates here, would not be in the interior of the circle? Okay, so we're going to have to clearly draw for this one. All right, so that means we need to be able to extract some information here. So right away, I think the easiest thing to determine is the radius, and that's going to be 5. Because remember that in the equation of a circle, it's always equal to radius squared. Right, so we just square root it and we get the radius. Now it's also really helpful or necessary to get the center of the circle. And to do that, we simply switch the signs. So our h is going to be -3. Our y is going to be 1, right? Maybe I should make that clearer. We're switching the signs of these numbers in here. Okay, now let us draw. Whoa, okay, that's a little crazy. All right, so we've got our x. Hello. We've got our x and our y. All right, we've got a center of -3. Let's call that -3 and 1. Okay, that's our center. And we have a radius of 5. So I think I'll do this in a different color. And so our radius is going to go out in each direction. It's going to help us draw our circle. So if we go up from -3, 1, we go up 5, it's going to be 1, 2, 3, 4, 5. That's going to be at 6. So it's going to be here. And then let's go down. If we go down from -1, it'll be 1, 2, 3, 4, 5. It's going to be -4. And that'll be here. If we go to the right from -3, 1, 2, 3, 4, 5. It's going to be at 2. Okay, but we're still going up, right? We're still, everything is from this point here. And then if we go 5 to the left, it's going to be -8. And so that's going to be here. All right, and we can start to draw our circle. It's not going to be good. I'm just telling you now. All right, it's going to be as good as I can do. This is not my strong suit. Yeah, that's not too bad. Okay, anyway, then we start to just go up, we look at each of our coordinates in the answers. So we go to 3. Well, already we can see 3 and 2 is going to be outside. So A is going to be our answer. All right, now it's possible that they wouldn't put this at the top. They would maybe put this in D, and we would look, though. We can look at 0, 0 is clearly it. I think I'll use a different color. 0, 0 is right here. That's in. All right. Remember that they're asking us for what is not inside. Maybe I should have written that. What is not inside the circle. That's what they're asking us for. We can look at -3, 1. Well, that's the center of the circle. -7 is right here, and 3 is still within the circle. Okay, so all of these. So it's all about, the takeaway here is being able to figure out what is the radius and what is the center of the circle if they give you an equation of the circle. Okay, my dear, have a wonderful day and take care. Hope you enjoyed circles. And if you didn't know, you probably don't need to answer those questions anyway. All right, you take care of yourself.